All right, let's get started. All right, welcome back. Yeah, so let's see. Yeah, so we just completed our third module, right, where we introduced the language JavaScript as the programming language of the web, right? That allowed us to, introduce a lot of techniques that we had been promising, right, when we were looking at HTML, CSS, that we would be able to build component-based applications, right? That we could build, smaller, reusable, modular pieces that could then be combined to build more complex user interfaces. And yeah, definitely we got definitely better, right? Because at first it was all hard coded. It was all declarative, right? It was just static text, and then when we moved over to JavaScript, we were able to create functions, right? That could write algorithms and use data structures, right? And create the user interface as a computation, right? Something that we could compute what the user interface was based on the transformations of some data structure into an equivalent user interface. So yeah, so we're going to continue doing that. Even though yes, we have we are fairly programmatic, and we are dynamic in the sense that we can compute things, right? We can make decisions. We're still static, right? In the sense that the data that we are rendering is static, right? We have a whole bunch of arrays that contain a set number of courses, a set number of modules, and so that state, that data doesn't change over time, right? We can't, users can't, for instance, modify those, right? You can't modify or add a new course or delete a module or grade an assignment, right? So there's no new data that's being created or deleted or updated at all, right? So we want to have that capability, right? That the state of the application, right, can change over time, right? Can evolve over time as users interact with the application, right? By clicking, dragging, typing, they're going to be creating a stream of events, right? As they interact with the user interface, and we need to be able to consume those events, right? Transform them into modifications of the data, right? Of the state of the application, and as the application's evolves over time, the data evolves over time, we need to re-update the user interface to reflect those changes. Okay. So yeah, so that's going to be the focus of today's lecture, as well as when we come back after the break, we'll continue discussing this. One of the limitations that we'll discover is that all those changes that we can modify and we can manipulate the user interface, those will be all just transitory, right? They won't be permanent. So yes, we will be able to create new courses, create new modules, delete assignments, right? Change the title of a course. So we're going to learn how to do that, right? Create forms that we can fill and create data and affect the state of the application. But none of that will be permanent, right? If you refresh the screen, right? If you do a Control R, right? All those changes go away, Right? We have no mechanism right now to make those changes permanent, right? For the browser, for the application to remember any of those changes. Okay. For that, we're going to need the help of a server, of a database. Okay. So that we can have a permanent storage solution, and that we'll have to wait until we come back after the break. But first, we need to learn how is it that we can capture all that data, modify the user interface over time, right? And then we'll figure out how can we make those changes permanent, right, when we come back from the break. Right? So we're going to get you started with assignment 4 today, which will give us a chance to practice these skills, right, of handling user inputs, filling out forms, and modifying data structures. So we'll get you going with that. Also today, we're going to review the, we're going to take a look at the upcoming exam next week, right? Exam 1. So we're going to take a look at questions from prior exams. We'll go over and solve it together, right? And I'll share the PDF document with you so you can take it home and as a reference. So we'll do that in the second half of the lecture today, and also we'll have quiz 5 towards the end. And after the quiz, if you want to stay afterwards, I'll stay if you have any questions, you need help. So I'll have like an office hour, right? If you want to do a one-on-one, and if you're having any issues with the assignment. Also, assignment 3, we're gonna postpone the due date till Friday, right? So last week there was supposed to be a storm. It never actually came, and it kind of like wrecked a little bit of the schedule. But I don't think it should have any effect on the due date for assignment 4, which is due after the break. So I think you should have plenty of time to keep that in the same due date. I think it's the week after we come back after the break, right? So that should just stay put, okay? What else? I think that's it. Any questions? Yes. So you only need half of the time. So it's 100 minutes. So the first half, if you have any questions before the exam, we can go over, right? Maybe you've gone through the exam again, some of the questions I gave you, and maybe you have questions before the actual exam. So we'll do a Q&A before, right? And then once you're ready, we'll start the exam. Yes. Yeah. Yeah, the exam is just one very long quiz. Yeah, same thing. Open notes, self-graded. You'll probably see a lot of the reusing some of the same questions from the quiz. So it's a good idea to go over the quizzes prior. Yeah. So make sure your laptop is can stay on for 100 minutes. But I think there's plugs in some of these seats. Okay. Anything else? So the material of the exam next week will be up to whatever we see today, right? In the first half of the lecture. Okay. All right. Let's get started. All right. So basically, we want to be able to maintain and handle application state, right? And what we mean by state is that is if you take all the collection of all the variables or constants, right, in an application, right, and you collect all those variables and their current values, okay. If you could take all the data at a particular point in time, right, we would say, right, that the application has that specific state, okay, and usually all that data, whether they are data structures, arrays, primitive data types, okay, all those variables are collaborating to render an equivalent user interface that represents graphically, right, some particular state of the application. Make sense? Right? And that's one of the reasons we abandon classes and for functions, in that the functions are by design stateless, right? If you take a function and it's the addition function, 2 plus 2 is always going to be equal to 4, right? It's not going to change over time, right? It's stateless, regardless of what time it is. For the same input, right? It's always going to give you the same output, right? So that's the definition of a function. And if you take all the possible states that the application could be in, right? That gives you a kind of like a map of all the possible states that the application could be in, meaning all the combination of all the values of all the variables in an application, right? That would be a combinatorial explosion of all the possibilities that of all the different states that an application could be in. Yes, right. But if it's a function, you could say that for the same input, right, it's always going to give you the same state or the same output. Right? So if you're going to test and you're going to validate, you're going to create automated tests to check to see if the application is doing what you expect. You could write kind of like a map, maybe like a truth table, right? That you have all the inputs, right, and then on the other side, all the outputs, right, of having calculated a function that would say, well, these are all the output that I would expect given all these inputs, right? And then you could just iterate over all the inputs and verify that the function is indeed computes the value that you're expected. There can only be one output for a particular combination of inputs. Yes, and so that's one of the reasons we kind of abandon classes for functions, because if you have a function and it always gives you the same output for the same input, well, there's this, you can enumerate all the possible states. Now it becomes so much more harder, right, if the function can now maintain state, right? If classes can maintain state, because now not always 2 plus 2 is 4, right? Now the function, if it remembers something, it could be that the output is different as the state changes over time, right? Like for instance, an account balance, right? If you ask for the balance and you have the operation, deposit or withdraw, right? If you deposit $100 and then deposit again $100, the balance goes up, right? So now there's a remembering. It's the value, the output is actually based on not only the input, but whatever the current state was previously. Yes, so that creates an even higher, bigger explosion of possible states that the application could be in, right? So it makes it much harder to test, right, that the application is indeed behaving as we expect. So state management introduces a much higher level of complexity. So anyway, so state is the collection of all the possible values at a particular time in point in time. Yes. Now, as the user interacts with the user interface, right, the state changes. They might add a course, they might delete a module, they might update an assignment, right? They apply CRUD operations. Create, read, update, and delete. Those are the 4 basic operations that humans can do with an application. They can create data, they can retrieve data, they can update data, or they can remove data. Those are the 4 basic operations on any data structure. Okay? So as they add, remove, delete, and update, they change the state of the application, and the user interface needs to re-render, right, to show feedback that their operation actually went through, right? If they deleted something, you must re-render to show that item you deleted is no longer there, right? Or if you added something or you updated something, you need to re-render the screen to show that indeed the state changed. Yes? Right. So we need to learn how to do that. Okay, so here's a simple, trivial example, right, where we have a component called a counter. And so here's our first example of a state changing over time, right? And our expectation is that, right, the user interface, represents the current state. Typically, right, if you have a a variable like count equals 7, we render that count, it renders a 7. It behaves as expected. The function is calculating the correct graphical representation of the counter. Yes. Now, what happens if now we can receive or handle user input such as clicking, right? You're clicking, right? And we can now handle and invoke a function that updates the state of the variable, right? Like you're incrementing the counter or decrementing the counter, right? Now, the expectation would be that this indeed changes over time, right? That if you increment it, now it becomes 8, 9, 10, right? Or if you click on minus or down, right, it goes, 10, 9, 8, 7. And indeed it works. It does. You can see the output, you can see the live value of the count. Unfortunately, it is not reflected in the user interface. Right? The user interface renders at 7 and ignores any changes to the variable. Right? It is not rendered. Okay? And this is because React.js uses a lazy strategy. Right? It tries to minimize any updates to the DOM. Right? Only when it's absolutely necessary. Right? It's a very expensive operation, right, to go out to the DOM and manipulate the DOM, either writing to the DOM or reading through the DOM. Right? It's very, very expensive. So React.js tries to minimize or economize as much as possible going out to the actual DOM. Right? And what it does is that it maintains two versions of the DOM. There's the real DOM that we've already known. Right? We can see that in a browser. Right, whenever we are looking at a particular page, we could see the browser, right? And this is the DOM that we've come to be familiar with. So this is the DOM data structure. So this is the real DOM, right? And React.js tries to avoid as much as possible touching the real DOM, right? Because it's very expensive. So instead, it maintains what is called a virtual DOM, right? It's a representation of the real DOM, but in a much more compact, much more efficient representation of this data structure, right? Which is very, very fast to update. Okay, so any changes to the state of any variables, right, that manipulate the virtual DOM, okay, those it makes them really, really fast, right? Very, very performant. And only if it detects that the DOM has changed, the virtual DOM, if it has changed before and after any events, okay, will it actually go and render, right, the real DOM? If there's any changes in the virtual DOM, it goes ahead and identifies the pieces of the virtual DOM that have changed, and then it goes back and does some surgery, right, and it updates only those pieces of the DOM, right, that correspond to the virtual DOM, right? So if for instance, ideally, right, if this H2, if this count has changed, right, in the virtual DOM, right, if the change has happened in the virtual DOM because the count has changed, it would then go and update the real DOM, right? We would know, oh, this H2 in my virtual DOM corresponds to this H2 in the real DOM. It has changed. I have to go and actually render that, re-render, right, redraw that H2. Make sense? All right. Okay. So, but as far as React is concerned, it has already updated the DOM. It drew it, right, with a counter equal to 7, and nothing has changed since since it last rendered the user interface. Okay? It is completely ignoring the count, okay? because it says, well, you might have all sorts of algorithms happening, right, inside of your loops, right, and your algorithms, and you have maybe you're iterating over a variable. It can't keep track of all those variables that you might be looping around, right? So instead, it ignores any changes to variables unless we tell it to not ignore certain variables. In particular, this one. We would not want this count to be ignored. We want to be able to tell it. It says, hey, I know you ignore most changes to most variables. This one you should not ignore, right? If this changes, go ahead and re-render the piece, right, that it is responsible for. So the way we do this to tag, right, or to make these variables special is to use a hook called useState. Right? So useState is a React.js hook that allows us to redeclare the variable, right, in such a way that we can then manipulate or tell React.js that it should not ignore this particular variable, right? And the way it's done is that we use the hook called useState. Right? We use the same variable name, but in this case will be a constant. Right? We initialize it. We use useState takes the initial value of the variable, just like count equals 7. Now this is the equivalent of saying that count is equal to 7. Okay. Yeah. And syntactically, this is identical. Syntactically, right? Count now is a variable or a constant, right? Whose value is 7, and it renders the same way like before. No changes there. Everybody good? Okay. All right. So that's the part where we can initialize and read, right, and render the current value of this. Now we call it a state variable, right? Now it's a state variable. Any changes now to the state variable will be rendered, right? But only if we use the mutator function provided by React. Right? React will give us a function that should be the only way that we update this variable, state variable. Notice that now count is a constant. We should not be able to update count. We shouldn't be able to say count plus plus because it's a constant, right? The compiler won't let you. It says, wait a minute, no, you can't update a constant. Yes? So the only way we can actually update the constants is through the mutator function that React.js gives us. Yes? So that's the naming convention, right? The naming convention is that if you call the variable count, then the convention is that you use a set and then count with capital IC. Doesn't have to be, right? This could be XYZ, you know, and then, so as long as you use whatever you called it, right? That is you treat it as a function to update the new value of count. Yes, right. So indeed, there might be a question in the quiz or the exam where I'll call this XYZ and I'll call this, you know, ABC, right? And it should still work just fine, right? As long as you treat it as the function to update, right? If you use ABC to update XYZ, it'll work, right? Indeed, notice that we are using the square bracket destructor syntax here. See that? Yes? Meaning that useState actually, what it returns, this function returns an array that has 2 items, right, in the position index 0 and index 1. The first element is the current value of the variable that you're declaring. And the second argument, the second item in the array is a function that you're supposed to use it to tell it what the next value is, what the updated value should be, okay? And also this function tells React.js, notifies React.js, hey, the value of the state variable has changed, okay? You know, at your earliest convenience, please re-update the DOM, right? Wherever that variable is used, go ahead and do your thing, re-render the user interface to reflect those changes, right? It is us telling React.js, hey, there's a new value, right? Well, actually, React.js, what it'll do is that it will, you know, you pass it a new value, it'll compare the value, this new value, compared to the old value. It'll compare them and says, okay, well, if it did change, then it'll go and update the user interface. If the state hasn't changed, meaning you update from 7 to 7, right? It'll compare the old value and the new value, says it hasn't changed. I'm not gonna. There's no point in me re-rendering the screen, right? Because nothing has changed. There's no point of me wasting any cycles in doing anything to the user interface, right? So oftentimes it will happen that you'll have a bug, right? And I'm clicking, right? But my user interface is not doing anything, right? And usually what will happen is that for some reason, the value that you had before is the same value that you're passing through. Yes? And the React.js will compare the two. So this is the same. I'm not going to update anything because it used to be 5 and you're passing me 5 again, right? Usually those are easy to debug. In most cases, the complications come if you're talking about an array, right, or complex data structure, right, that you're updating a whole data structure. Yes, and you think you changed the the date of birth of the user inside of a project, right? You think you updated it, but indeed you didn't, right? And so React.js looks at the two states; they're the same. It doesn't bother updating the user interface. Make sense? It's a very common bug. So this one is trivial, right? When we click on up, we are setting the count to whatever count was plus 1, right? So from 7 it becomes 8. React.js compares 7 with 8. It changed. It looks in the DOM to see who depends on count. Ooh, this one. It will re-render this H2 and only that H2 because that's the only place where count is being used. Everybody good? Right? And if you had count in a whole bunch of places in your DOM, right? Every element in the DOM where you have count will update, immediately, or well, not immediately, at its earliest convenience, right? This is actually a very common strategy, like for rendering engines in general, right? Like graphic rendering engines, usually, right? When you're perhaps in a game or whatnot, right? You typically are like in a very quick while loop, right? That you're computing the state of all your players, right? The missile that is flying around, the person who's running, right, and the car who's spinning, whatever, right? And you have a data structure that represents all the different state in your game. Yes, right? And as you're computing the positions of the of the missile and the car and the players, right, in the 3D space, you're computing all these. Maybe you're computing it, many times per second, right, per frames, many frames per second, right? At some point, you need to tell the rendering engine, go ahead and pump this to the screen, right? You have to render, right, the new frame on the screen. Yes, right. So typically, at the end of the loop, right, when you've updated all the state of all your variables, you tell the rendering engine, go ahead and render it. Okay, and then it gets it gets scheduled, right, for the rendering engine to render the next frame. So it's very common. It's a very common strategy in rendering engines that there is a function that you call, right, to tell the rendering engine that, hey, this is the new state. Go ahead and render the state in the user interface. Very common strategy. Everybody good? Okay. Okay. So here we've seen the example of a very simple useState using a primitive data type of an integer, right, of a number. But these variables can be of any data type. It could be Boolean, right? It could be strings, right? It could be objects. It could be arrays, right? They could be very complex data types. So let's go through some of these, right? And here on the slides, and then we'll pop over to the assignment, and we'll do some exercises from the lab. Okay, all right. So let's look at another one, Boolean state variables, and this will also give us a chance to introduce form elements, right? We did play around with form elements way back in HTML, right? We looked at checkboxes and radio buttons, input fields, right? But we couldn't do anything with them, right? We learned about styling them and positioning them and initializing their values, but we couldn't programmatically do anything. So here's our simple checkbox. It could be a radio button too. So checkboxes and radio buttons are meant to render, right, a an expression that is either true or false, right, or checked, unchecked, right? It's a binary value, right? And the way we represent binary values in programs is by using Boolean expressions, yes, or Boolean variables. So here's an example of a Boolean state variable, done, right, and then its mutator set done, and done has an initial value of true. So done is true, and then you can use the done like you would any Boolean variable, right? Here we have it being used in a ternary expression, right? So this paragraph either renders done or not done, right? Based on whether done is true or false. Pretty good? Right, so you can treat it like any other, Boolean expression, Boolean variable. Here's another one, right? Again, being used in an AND operation where we can either display or not display this div based on whether done is true or false. Pretty good? Right? So if it's true, that means that this renders by default. And this is done is also renders by default. Yes? But here's an input field of type checkbox. Right? It could be a radio button too. And so it's a checkbox. And we can initialize its value using the checked, and the value is either true or false. So it displays as checked if done is true, or unchecked if checked is false. Right? So this would initially display as a checked checkbox. Right? And then it has an event handler on change, that very much like the on click here, right? So there's a whole bunch of event handlers, right? That can handle all sorts of user events, right? The simplest of which is clicking. Right? You click. There's also double click. Right? There's a whole bunch of them. There's a whole family. There's hover. There's you can check if a mouse hovered on top of something, or when it exited or entered, right? We could use for highlighting, right, and giving some nice cool effects. But let's look at the two basic ones: on click, and the other one is on change. On change allows you to handle changes in the value of a particular variable, right? Of that input field. And that input field, right, if you click on it, if you click the checkbox, the checkbox will change its value from checked to unchecked, right? And so what we're using here is to invoke, right, the set done, and we use it to toggle, right, the value of done. It was true, now it becomes false. If it's false, it becomes true. And what this does is that it now, by setting the value of done, by updating the value of done, right, everywhere you see the variable done, it will be re-updated, right? So this one will be re-rendered, right, so that it's false, it renders not done. This one, again, here, this div will be now not shown because it is false, it's gone. And it's here, right? It was true, true, and now it's false, so it displays the checkbox as unchecked, yes, everywhere in the user interface. So again, the React.js keeps tabs, right, on all these dependencies, right? So it doesn't have to re-render everything, but there could be a lot of user interface down below or above that have nothing to do with done, right? And they haven't changed, so there's no point in re-rendering everything. It'll do some surgery, just to update those things that that changed, that did change. It'll do a comparison, right, of the DOM tree. It'll say, okay, well, here's the DOM tree before, here's the DOM tree afterward. We'll do a difference comparison. It'll identify the things that did change, and it will surgically only change the DOM that was affected. Yes. So again, trying to maximize performance, trying to be as efficient to manipulating the DOM, not manipulating unnecessarily. Make sense? So here's another one illustrating the use of strings, right? So here's a state variable where the value is a primitive data type string. Yes. So first name has an initial value of John, and it has its mutator set first name, which is going to allow us to update the value of the first name. And so here's, wherever we see the the variable or the state variable being used, like in this curly bracket, it will render, right, John. Here we're using it to initialize the value of this input field, right? So you will see the input field display first name, and then as we type in the input field, right, for every single keystroke, right, the on change will be invoked. Just like in the checkbox, right? Every time we click on the checkbox, it will invoke the on change, right? And then we can handle it. Yes. The initial value of first name, right? It's as if you would say, let first name equal John. Yep. You can provide initial value. So for every keystroke, it will invoke the on change, right? So if we type space D O E or whatever, right? Every single keystroke, it will invoke this with the new value of the input field, which includes the previous value plus, right, the new character that you typed, right, that you clicked on, right? And all that is included in a optional event parameter to the event handler, right? Which you can ignore, like we did before here in the event handler. We ignored it. It's being passed, right? But we're not using it, so we don't even declare it in the event handler. See that, right? Here we do care about it because the actual value of the input field, the current value of the input field, is embedded in this event object. And that event object has a specific data structure. It has a target property that has a reference to the actual DOM element that changed, right? Whether it was the button that was clicked or the checkbox that toggled, right? Or in this case, the input field that I typed, okay? So this e.target is a DOM element. It's a reference, it's a pointer, right, to the actual input field or the DOM element that generated the event. And for input fields and text boxes, right, or dates, right, date elements, or select statements, there is a dot value that has the current value of that field, right? So if you type a new character, it'll be all the old character plus this new character will all be available in value. So what we're doing here is that we are updating the first name for every single keystroke. For every single keystroke, we're basically accumulating all the small little changes, keystroke by keystroke, we're accumulating all the first name. And as you type, right, we'll see the first name change, right, increase or delete, right, whatever the first name is as we, for every single keystroke. Pretty good, right? And so here's another example, entire object, right? So here's a more complex example where now the person state variable is not a primitive data type, but it's a complex data type, right? That has two fields, a string product property and a numeric property, right? Age, name, and then we have two input fields that allow us to manipulate each individual field, right? Here's an input field for the string name, and here's an input field for the age. Okay? And so the values of this input field will be person.name. So this one will show Peter, right? And this one will show 24, right? The person's age. Yes. And now we can type, right? We can type at each input field, and as we type, it will call the on change for every single whatever field we're updating. And what we're doing here is that we are computing the new object, brand new object, which will be, notice the curly brackets, right? we are replacing the old object with a brand new object, yes, which constitute a deep copy of the old object, dot, 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 person. This copies all the fields from the old object, and then comma, an override of one of the fields, right? We are overriding only the name field. So we're copying everything over, which might include first name, last name, middle initial, date of birth, salary, date of hire, right? It could copy a whole bunch of stuff over, but then we're going to override that one field, right? Because we are typing the name. So we are overriding the name will be whatever the target value is. See that? Okay. So we are setting a brand new object. We're updating the state. The person, wherever the person changed, we're going to go and re-update wherever person that name appears. We render it again. Everybody good? Same thing with the age, right? If we're typing the person's age, again, we deep copy the old person into this new object, but we override the age. Right? The age is now whatever new value as you type. We make sure it's an integer, right? We're expecting an integer, a whole number, right? And then we re-render the age. Everybody good? Okay. All right. Finally, one more. Arrays, right? So arrays, just like objects, it's a more complex data type. Although this is a simple one since it's an array of integers, right? It could absolutely be an array of objects, right? An array of modules, an array of courses, certainly, yes. But let's start off with something simple: an array of integers. So here's my state variable array and my set array, which presumably would allow us to set the new array at some point. Okay? So here we have a couple of event handlers. Okay? Well, actually, let's look at the rendering first. Let's look at the rendering. How are we rendering this? So we're rendering it with a button here, right? That allows us to add a new element. Yes, if we click this button, it will add a new, I believe, a random element at the end of the array. Right? And we're rendering over the array inside of a UL line, a unordered list, and here's each item in the array, and we're rendering as a simple line item. Right? And each one of the items. So this will be 1, 2, 3, 4, 5. Right? Each item in the list. Everybody good? Now inside we also have a button, right, for each item. So it'll be 1 and then the delete button, 2 and then a delete button, 3 and a delete button. Yes? Okay. So we'll come back to this in a second. Let's look at this on click. So at first, this renders an array of 5 numbers. So this will render 1, 2, 3, 4, 5, right? For each one of the array. And so to add the element, right? Let's look at the add element. So when we click on this, we call add element. Notice that syntax. So on click is calling add element, right? And we just use the name of the function as opposed to, look at this, compare this syntax with this syntax. Here we have on click, and the function is being invoked, right, inside of this a lambda function. See that? One of them is embedded, whereas this one we're only using the name of the function. See that? Why use one or the other? So if the function is going to be invoked with no parameters, like here, we're not passing any parameters, then you can use this more terse syntax where you just provide the name of the function and it will invoke that function. Yes? But if you need to pass a parameter to the function, right, then it has to be embedded inside of a lambda function like this. Okay? We call this a closure. Right? And closures allow us to remember things. Right? And so I'll come back to it in a second. But the only other reason is that if we are calling and we need to pass parameters, like here we're doing a passing a parameter, we have to use this syntax. You cannot use this syntax. Like for instance, you would never write add element and then in parentheses pass something, right? Without putting it inside a embedded function. Otherwise, it will cause an infinite loop, right? What will happen is that the whole component will render. It will immediately call the function, right? Even before it gets, to the continue, and the calling of the function will cause the component to re-render, which will cause it to call the function again, which will cause it to re-render again, which will call the function again. So we'll go into an infinite loop, right? And you'll get an error saying, stack overflow, blah, blah, blah. You have reached, the maximum amount of stack something, something, something or other, right? And the only way to fix it is to kill the browser, right? Or kill the page, yeah, okay? So careful, it's a very common issue. In particular, which right now it has very little consequences other than you have to just kill the browser. Right? Later on, we're gonna be talking to servers and databases, right? And so your infinite loops might cause a server to crash, right? Because you'll be sending an infinite stream of requests out to the server, right? And the server will interpret this as a denial of service attack, right? That you're trying to, right? Sabotage the server, right? And the server, right? And then Heroku or React.js will label you as an attacker. Anyway, so let's look at the add element. This syntax, we're not passing any arguments, so we could just use the name of the function. Yes. So when we click on add element, let's look at it. So here's add element, and what we're doing here is that we are calling set array with a new array. See that? It's a new array, which is basically a clone of the old array. I am copying over all the values 1 through 5, comma, and then I am randomly picking a number, right, from 0 to 100. Okay, so I am randomly adding or appending a value at the end of the array, and since the state changed, right, it will go ahead and re-render. It will re-render this, adding the next value at the end. Okay. Now it doesn't re-render all the items. It will only add the brand new line item at the end. Okay. But this is a little more complex, right? Because this is an item that didn't exist. It's not like I'm updating a value from a DOM element that existed before, like we did before, right? These cases. In this case, I am updating the value of an input field that already existed. It was already in the DOM. Yes? Right, so this is less challenging than this one, because here I am not only rendering line items that were already there, but now I am adding a new line item, a new DOM element that wasn't there. Yes? Right, to represent this new element in the array. Make sense? Right. So because it's a little more challenging that we're adding a new line item that was not there, the DOM element was no longer there, to simplify its mechanism internally, React.js asks us to do something for it, right? So that to make it easier for React.js to keep track of the items that were already there, right? And then compare it against new items that were not there, okay? And they're changing over time, right? It asks us to give each line item a unique identifier, right? Right, so that it can create a map and check to see, okay, well, I already have these 5 line items, and I'm going to add a new line item, yes? And to distinguish them in the correct order, right, I need a unique identifier. So React.js, if you have a map that you're iterating over a data structure, right, it asks us to add a key with a unique identifier. The easiest thing to do is to use an index, right? And so these are just 0, 1, 2, 3, right? So you're guaranteed to be unique. If this for somehow is not unique, you get an error saying your keys are not unique, blah, blah, blah. It'll still render, but you'll get you'll be scolded. React.js will scold you. For instance, we couldn't use item because item is not guaranteed to be unique, right? In the array, we could have repeating values, right? We could have 1, 2, 3, 1, 2. Yes. So the items are not necessarily unique, right? Or these could be objects, right? It could be an entire course object that have unique identifiers, like ID RS101, RS102, or something, right? We could use that if it's a complex data type. Okay. So add just appends a new line item. It just iterates again, right, and renders all the items, in particular the new line item of having added a new array item to the state variable. Everybody good? Right. The more interesting one is the delete. Notice that each one of these objects, each one of these items, is being rendered with a delete button right next to it. Yes. Okay. So once it renders, notice that if you click on any one of those 5 delete elements, we need to be able to know which one did you click on. There's 5 of them. There's 5 buttons. Which one is it? And to be able to distinguish, what we're doing is that we're passing the index, right, representing the item that we want to remove, right? So if it's the first item, this will be 0. The second item, this will be 1, and so on and so forth. Yes. And so that if you click on the third item, we click on it, and so we pass index 3. Yes. And then the way we use that 3 as an index, what we do is that we compute a new array. We create a brand new array, but filtering out the item whose index is the item the one we want to remove. Right? Meaning, recompute the array, but leave out the one whose index is the one we want to remove. Right? So it'll be missing that one item. Right? So we set the new array, and then you'll see that the item is gone. Yes, from the array. Make sense? Right? Now, for this to work, after having iterated, it needs to be able to remember each button needs to be able to remember what index was as it was iterating. Right? That's where the closure comes in. The closure in JavaScript is able to remember what the state was when it was declared, when the function was declared. Right? So all of these functions take a snapshot, right, of what the state was as it was iterating over this loop. Right? So each one will remember that index at the time of this declaration was 0. And then the next loop, right, it will remember that the index was 1, and then it was 2, and then it was 3. Right? So that's a feature of this closure, right? Remembering the context, of when the function was declared. Right? And it will actually execute at a later time in the future when you actually click on it. It'll have to remember, oh, what was index, right, when I was declared? Oh, it was 3. Okay, then I'll call delete element 3. Everybody good? All right. Okay, so this is an intro to state variables. These are all exercises from the lab section of the 4th assignment. Let's get started with the lab assignment, right? We'll demonstrate some of these in as lab exercises, okay? And let's see how far we can get. All right. Okay. Any questions so far? Everybody was still with me? Okay. All right. Okay, let's see. All right. So yeah. So these are the labs that we've been playing around with. Right. That we had Canvas. We had Hello. Right. We had the labs. Right. And we had the assignment 3 was the default, and then we had left assignment 4 as a placeholder. Okay, so let's get started with assignment 4. All right, so assignment 4. So assignment 4 is going to give us a chance to talk about how to maintain state. Right? And what we've demonstrated so far is what we call component level state, right? State within a component, right? So these are all self-contained functional components that are maintaining their own local state. Yes, right? And it's fairly easy, right? We use the useState, right, and the mutator, and so on and so forth. And now the interesting part is when components need to share state among themselves, right? Now the easiest way for components to share is that whoever is maintaining the state can pass, right, these state variables to other components that are its children, right? That I am rendering my children elements, and I can pass these state variables to my children through attributes, right? I can pass an attribute, right? And then it can render it and whatnot. So that's the easiest way. You have a parent component passing a state variable to a child component through attributes. Yes, right? And if that's all we knew, you could just use that strategy for everything. Okay. It gets more complex when you have state that is not strictly hierarchical, that is just a parent sharing with its children, right? What if you want to share it among siblings? Yes, you want to share cross with your brother, right? I'm not your parent and you're not my child, but I still want to share data with you. How do I send it to you? How do I share it with you, right? And again, one way would be to say, hey, let's find a common parent, have the parent deal with the state, and then have the parent then just share with both of us. Yes, and then we can communicate that way. We can update the state in the parent, and then the parent can tell all its children. Again, if you can create the hierarchy, you can absolutely just use this strategy for everything. Yes. Now, these dependencies become complex, right? When sometimes you find yourself that to maintain these strategies, you have to pass through multiple attributes, right? And there might be a whole chain of objects in your hierarchy that don't really care about the data, right? But they still have to pass it down for whoever actually needs the data, right? So we'll be talking about other strategies of how to share state across components, right? In what we call application level state, right? So for instance, if somebody logs in, yes, we would want to know, or there might be many components that would be interested in knowing who is currently logged in, right? Maybe in my shopping cart, right? And my checkout, in my billing information, my profile. They're all interested in knowing who is the current person who's logged in. Yes, right? So ideally, this would be available in some global context. Yes, that anybody who's interested could pull this information from. Yes, so strictly speaking, it doesn't need to be at any one parent that shares it with any one children. Instead, we would like to have some global state. Yes. So for that, we'll need to introduce an entirely different strategy, right? And that's going to be the kind of like the second half of the labs, right? But let's first play around with component level state, right? Okay. So we already have an assignment 4 component, I believe. Yeah. So let's take a look at. And we have this welcome, and I think we have assignment. I guess maybe not. Assignment 3 now, or labs. Here's labs. Oh, here's assignment 4, I think. Yeah, this is assignment 4. There we go. Okay, so let's play around with some of the same examples that we just saw, right? Let's see them actually work. So first, let's learn about event handling. Okay, so we want to be able to know how we can respond or handle just simple clicks. Okay. So here we have two functions, hello and life is good, and they are being invoked, right, by declaring an on-click event handler, right, on these two buttons. That here we see the syntax of calling the function hello with no arguments, right? Whereas here we're seeing the syntax of calling a function, but in this case we are passing an argument. See that? Right. So again, if you're not passing an argument, you can use this more compact syntax of just providing the name of the function. But if you need to pass an argument, you need to use this syntax. Right? So some people, what they do is that, so they don't have to remember that there are two syntax, they just stick to always using this syntax, regardless of whether you're passing something or not. Okay, that way, you wouldn't mistakenly use this syntax and then mistakenly add the parentheses that would get you into trouble, right? So I would suggest just stick to this one syntax, right? Whether you're passing something or not, right? So you don't have to remember. But nevertheless, here's an example of calling hello, which does an alert, whereas this one passes good and alerts life is good. Or here is a more complex event handler that has a body, right? Notice that this syntax has no body. See, no body, right? So meaning this is a single line, and it's an implied return. Yes, it's an implied return. Here we don't have any return, right? We just have curly bracket, two function calls, right? So that if you have more than one line, you need the curly brackets. Yes. So we can bring that into assignment 4. So this is the click event. So assignment 4, there it is. So click hello, there it is. Life is good, and then this click calls both of them. Okay. All right. Okay, so that was just to introduce the on click. We can also this example just makes sure, right, to point out the difference on whether you're passing arguments or not, right? So again, this is illustrating that if you're passing arguments to this add function, to make sure that you are using this syntax and not this syntax. Right? Careful. This will get you into an infinite loop. Right? Okay. And you'll have to kill the browser, right? Or at least that page. Yeah. Then here's a passing function. So not only can you pass variables, but you can pass functions. So here's a passing functions. So here is a component, right, that you can pass to the component. You can pass a function so that this component can talk back to the parent, right? Not that children should talk back to their parents, but not only can we pass data down to the component, but then the component can pass data up to the parent, right? So here's, for instance, we're passing to this function, we're passing a function, and then we're using that same function to call, right, to invoke the function and call the parent, right? So here's in the index, we're going to, in the assignment 4, we're going to import that component, right? And we're going to declare a function in the parent, right? We'll declare a function here, say hello, and then we're going to pass that function. We're going to pass the function right there. We're going to pass the function, right? So this is a reference to the function. We're passing a reference to the function. So this gets bound in the child component, right? Here's the function. Then when we click the button, we are invoking the function that lives in the parent, Yes, right? And so we can say invoke the function. There it is. So this function lives in the parent component. So this strategy is important, right? Whenever you have multiple parent child components that are inside of each other, right? And you have the state being maintained way at the top of the parent, but the child is the one who's handling the event. For instance, right, when we had the to-do item, to-do list in the prior assignment, right? We had the to-do list that was iterating over an array of to-dos, and then you had each item, each to-do item, we were passing the to-do object to each one of the children. Remember that? Yes? So typically you would have, in each item, you would have maybe a delete button or maybe like a done button, right? If we were done with the to-do. So that event was being handled at the child element, yes? But the state would normally be handled at the parent level who has the array of all the to-dos, yes? So for instance, if we delete the to-do, each child would have to notify the parent, hey parent, right? They're deleting me, right? And then the parent would have to update the state, right? Filter out that particular to-do, right? So that it would not render again. Make sense? Right. So in that case, the child will need to send an event up to the parent, and then the parent update the state. Yes? So this is the intent of this example, right? Where we can pass a function down to a child, and then the child can call us back. Good? All right. All right. So also, real quick, the event object that we talked about earlier, we can take a look at it of what it looks like. Right? I did say about the targets of the object. Okay. So here we have an onClick. We have an onClick, and when we click on it, as I mentioned earlier, there's an optional event that gets passed, right, to your event handler, right? And you can ignore it, if you don't care about it. But here, I just wanted to show you what this event looks like, right? There's a few things in the event object that we care about, right? In particular, is the actual DOM element that we interacted with, right? For instance, which button did you click? If you have 20 buttons, we would like to know which button did you click, right? That is embedded inside of the event object. Also, if you're typing at an input field, right, or a drop down or something, we would like to know, well, which input field did you interact with? Yes, that is also embedded in the event, right? There is a property in here called the target, which is a reference to the DOM element that received or generated the event. Okay, so here the only thing I'm going to do is I'm going to print the content of that event object, and I'm going to display it here as a JSON. I'm going to stringify the event so you can see what's in there. Okay, so I'm going to now bring over the event. What did I call it? The event object. So event object, there it is. So there it is. Right now it's null because I haven't interacted with it, but if I click on it, there it is. This is the entire event object. There's tons and tons of meta information here. In particular, we can see the target. There it is, the target. See that? It's a reference to the button that you actually clicked on. See that? Well, stringified. Right? So this would be a DOM object with the class, the ID, right, the text and everything. Plus, there's all sorts of stuff in here. For instance, where was the button, right? Where was the mouse, right, at the time of when you clicked? Right? This would be useful, for instance, like if you're using like a drawing program, right, and you're dragging your mouse, and you want to capture all the XY positions of your mouse, right? And then you want to maybe create a silhouette or something, right? Create a path or something. So that would be useful for you, right? As you're clicking, click, 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 right? And then you can, maybe, generate lines between them or something, right? There's also a timestamp, right? Like for instance, if you want to, you want to capture, debounce, or you want to capture time-based things. So you can also, for instance, capture whether, the control key or the shift key or the alt key were pressed at the time, right? So that you can do Alt click or Shift click, right, to select many elements on the screen. So all that is all meta information, in the event object. Yes. Most of what we're going to be doing, most of the time, we're just going to be dealing with the target. Okay, we're going to say e.target.value, right? And you see me do that a lot. Okay, right? So it's the event object in there. All right, component state. So here's the counter example that we were looking at earlier. So real quick, I'm just going to demonstrate how it behaves. And I'll actually copy the working version. And so we have the like that, and then we can bring in the counter example here, counter. And there's the counter. We can go up, so it renders, right? Or it goes down. So it changes and it re-renders that part, yes? And the Boolean, you can do that. The string is more interesting. Let's copy the string example here. So let's see it working. And let's paste it here and let's bring it in. So this is the string state variable. And here it is. So as I type, it changes. Yes. Notice that notice that if I don't have the on change, if I remove the on change, right, and I refresh, notice that I can't type. Yeah, I can't type because the event handler is not updating the value of the state variable. It is forever tied to the initial value of the state variable, which was John, right? And nobody is updating it. Make sense? Right. So that's why it never changes. Right. Unlike if this were an actual input field without the value, it would let me change it, right? But nobody's listening to any of these changes, right? No one's capturing it, and certainly the user interface is not being manipulated, right? Let me just add a here class name container fluid. I can't stand the fact that we have I don't have margins around. There we go. There's a little margin. I need some margins. All right, so let's continue. Date variable, you can do that. Okay, the object variable is interesting. Let's do the object state variable. So again, the interesting part here, right, is that, right, to update the new object, we are copying over the old person, and then notice we have comma. That means age is overriding whatever original value of age was. Right? We are, right, using the benefits of the new spreader operator, right? The fact that last one wins and overrides anything that was declared before. Right? If you had an age, it'll just override whatever age you had before. Right? So let's bring that over. So we have the object state variable. So here we have Peter, right? And as we update, notice that the JSON representation of the object changes on the fly. Right? Same thing for the value of the integer. Okay. And finally, the state array is also interesting. Let's declare it here. And let's bring that over. Array state variable. And there it is. So we can either create brand new elements, right, or we can remove whatever element that we want to remove. Make sense? Yes. Well, I mean, we are rendering a user interface, right? So we're using React only for the fact that we are using HTML as the rendering engine. Without React, you would just use logs, right? A console log, and yes, absolutely, this would work without it, right? And the original counter example, the first part of that example shows that it can work absolutely without actually rendering it. If you print it out to the console, you can see that the state is changing over time, right? And that only because React.js has its own internal optimizations of minimizing the time that it goes out to the virtual DOM, right? Then it needs to be notified to pay attention to those changes, right? And to propagate those changes over to the DOM, right? And we have to make that explicit, right? That yes, the state variables are changing indeed, right? In TypeScript, it shows you if you do the console log, the changes are happening. It's just that the user interface is not being updated, again, because of the optimizations and virtual DOM. Yep. Yeah, so it complicates the fact that we are rendering, we are using a rendering engine, the HTML. Yep. So up to this point, we've been talking about data that is self-contained, within a component, right? But more interesting is when that state wants to be shared across multiple components, right? So here's a trivial example where you have a parent component, declaring a state variable, and it's going to share it with a child component that is being rendered in the body, right, of the parent component. So here we have a child component. We're going to pass the counter to the child, right? And then the child is going to notify the parent that it wants to change the state, right? But that state lives at the parent, right, not the child. The child can notify us that they want the state to change, right? But the state, nevertheless, is maintained at the parent. Yes, right. So this is where we start complicating things, right? On how is it that we share data, right, and not just locally, but with different components, right? So let's create first the child component. Here's the child component. Right, and oops. So it's expecting that we are passing a counter value. And then we have a set counter, right? And so we are rendering it. The child component is rendering, and it's also handling the events. But again, the state is being maintained at the parent, right? And the parent could maybe share not only with this child component, with many child components, right? And each one would receive the same state, right? So let's create the parent component. Okay, and then let's bring it over to the assignment. This is the parent component. So there it is. So we have the parent component. So the parent component is also rendering the state, I believe. Yeah, so the parent component is rendering the counter, right? But it's passing the counter variable down to the child, and the child is also rendering the counter. So they're both, obviously, they both render the current value, right? As we increment, both change, right? Because they're both rendering the same state variable, right? But the state is not being maintained inside of the child. Notice that the child has no state, right? The child is a stateless component. It is not maintaining any state, right? So if you pass it 3, right, it will render 3. So it's a function. It doesn't maintain any state. So this one is very easy to test, to write a test function, right, to verify that it renders. If I pass it 5, it renders as 5. It works fine, right? And in the set counter, if it's plus, right, then if it's 5, it becomes 6. It's very easy to test. It's much harder to test the parent component. And the parent component could have many child components. right? Each one with its own, right? Well, actually not with its own. We're passing the same state variable to all the children component. They are all receiving the same state variable from its parent. Its parent is sharing it with many components, right? And each one has an event handler that is telling the parent to, right, to update the state variable, and then filter down to all the children, and it gets propagated across, right, and render appropriately. Yes. So we're going to be actually following this strategy, right, to implement Canvas. We're going to have Canvas maintain the array of courses, for instance, right? And it's going to share the same array of courses state variable, right, with the dashboard, right? So that the dashboard, in the dashboard, you can create new courses, delete courses, and it's going to notify the parent Canvas component to update the array of courses, because we're deleting a course or we are adding a new course. That's going to propagate up to the parent. The parent is going to append or delete from the array of courses, right? But it's also being shared with a courses component, right? Because the courses component is responsible to find the course, right, and render the specific course, new courses, right, that we click on, right? Yeah. Okay. All right. So application state. All right. So application state is an entirely different topic, right? And it entails, right, the complexity of doing this, right, of the parent and child, right? We absolutely could use this strategy of declaring state at some root component, right, and maintaining the global state of an application at some root component, maybe at the Canvas component, yes, right? And in the Canvas component, we maintain all the data structures, right? The arrays of courses, arrays of modules, arrays of assignments, and then we can pass them like we did here, right? We can absolutely pass the state down, right, to the component who is responsible for rendering it. For instance, at the Canvas component, we can declare the array of assignments, plus all the functions that I need to add new assignments, delete assignments, right, update assignments, yes, all in the Canvas component. But who's rendering it? The assignments, right? The list of assignments is rendering it, yes? So I would need to pass the array of assignments down to the courses component, and then the courses component would have to pass it down to the assignments component, yes? And if I am editing a particular assignment, I would need to pass them as well down to the assignment editor component, yes? So a state that is declared at a root Canvas needs to go through the child course, right, down to the assignment, and then down to the assignment editor where it actually is being rendered, yes? Okay. This passing of these attributes from the Canvas down to the courses, down to the assignments, down to the assignment editor creates a problem. Okay. For instance, does the courses care about the assignments? It doesn't, right? Because it's not rendering it. It's not handling any events, right? Right. And then the courses passes it down to the assignments. Now, if I'm rendering one particular assignment, that particular assignment doesn't matter to the assignments list component, right? It only really matters down to the assignment. So we had to pass it through multiple places down to the actual component that needs the state. Okay. So what I've created is a chain of dependencies, right, between all these components, right? That the dependency only exists because it is a parent-child relationship, that it's the only way to pass down data, correct? So a better strategy is to decouple, right, the dependencies, so that now instead of having to pass it down, maybe this list of assignments could live maybe parallel to this, right? So that it could be accessed from any component that is actually interested in those assignments. Yes, right? So for that, we'll need to introduce an entirely new strategy, right? And that will be Redux. We're going to introduce Redux. Redux is a library that is going to allow us to separate, right, state management so that it can be local, right? But it can also be at a higher local global state, right? That what components do is that they they can register and say, hey, I'm interested in this part of the state, and I'm interested in that part of the state, and I'm interested in that part of the state, right? If something changes, notify me because I am interested, right? Because I am rendering assignments, you are rendering grades, right? And you are rendering roster information, and you're rendering faculty stuff, right? And each one of us can just pick out, right, from this global state, which part are we interested in, right? And then remove all the chain of dependencies between parent, child, grandchild, great-grandchild, right? And remove the necessity of just passing down all this from the top all the way down to the bottom. Make sense? Right? So yeah, that's Redux, and we'll discuss this right after these messages. Let's take a quick break, and we'll come back after this.
Excuse me, Professor, you're muted.
Thank you. Okay, so let's go over some questions that you can reasonably expect from next week's exam 1. So here's a question where they're asking you, to see if you can work with arrays, okay, of simple numeric data types, and so they're saying, well, here's an array Q that has 5 integers, and what would how would you write the following code so that the variable W ends up with these values? Right? So you have 1, 2, 3, 4, 5, and the output is 1, 2, 6, 4, 5. Right? So it looks like that we have the initial array has 1, 2, 3, 4, 5, whereas this one has 1, 2, 6, 4, 5. Right? So how would we use the original array, right, so that we can compute a new array, so that I guess what we want to do is replace 3 with 6. And that's what we want. So let's see. So we know that certain operations, we have map, we have filter, right? We have find index. There's several operators that can compute a new array, right? So filter kind of creates an array that is smaller, presumably, right, than the original array. Map creates a new array that has the same number of elements. So maybe that could work, right? So if we say Q dot map, that will create a brand new array that has the same length. And as we're iterating, so A would then be 1, 2, 3, 4, 5, and so we would compare things here. We would say maybe as A, if A is equal to something, then return something, otherwise return that. Right? So what we could do here is that if A is 3 maybe, so if A is 3, right, then we would return maybe 6. Otherwise, we would just return the original value of A, right? So if A is not 6, we'll return just A. So we would get 1, 2, but when we get to the third, right, A is 3, we would evaluate to 6. So this would compute a brand new array with a specific value, right, having been replaced. Make sense? Right? So let's see. For the first question, right, the consider the following code snippet. So where it's this one right here, right? Where you want to do that. So the can I do that maybe? Yeah. So 1, 1. So 1 is Q, right? 2 is map, right? Then 3 is what? I guess A. And this would be what? 6, right? Oh, 3, sorry. 3. Just see if you're awake, right? So if it's 3, then this would be 6. Otherwise, it would be just A. Now, obviously, you could switch these around. So this would be, if 3 is equal to A, I guess you could say that, right? So this would be A or 3, right? 3, and this could be A. So it could be one or the other, I guess, right? Okay, so that's that. All right, so for question 2, so there will be from a collection of acronyms, right? Some random acronyms will pop up. Make sure you know most of them: HTTP, hypertext protocol, right? Hypertext transfer protocol, as opposed to what was there was a question that was wrong. What was transport or something, or transport or transfer? I guess, or transport. DOM, document object model. So this is a HTTP and DOM, and then 4. Okay, so 4. It says so we describe the behavior. We're describing the behavior of what this is doing. We're saying, okay, well, fill in the blanks above so that the input field. So there's the input field here, right? The input field has an initial value of Alice. So for this to be Alice, this would need to be value, no? So this is a oops. So this is so 1 we don't know. So 1 we don't know. How many we have? 6. 6. Okay, so 2 would have to be value, no? So 2 is value. So value is Alice. Then it says when you click first name, meaning, so if you click this, so if you click that, it says the input field gets focus, right? So the way we know how to do that is that top would be a label, right? That would be a label, and the ID of the input field is the same as the for attribute of the label, right? So for that to work, 6 would need to be, 6 would need to be label. So 6 and 6 would need to be label. This would need to be 4. So 1 would need to be 4. Okay. That would mean that this is an ID. This is somebody's ID. It's the ID of the input field. So 4 would need to be ID. Yes? 4 would need to be ID. And what else? I think that's it, right? Let's keep going. So when you delete the text in the input field, so initially it says Alice, but if you start deleting it and you remove everything, it shows a grayed hint that says Jane, right? So it gives you an example of what we're expecting you to type, meaning we're expecting you to type a first name, So for that to happen, 3 would need to be, so here's a quick clue, Jane, right? So 3 would need to be placeholder, right? So placeholder. And finally, so if you hover over the input field, right, a tooltip appears, right, on the input field that says, type your first name. So type your first name. So for that to happen, right, 5 would have to be title, right? Okay, so this one is giving us a couple of arrays, right? Y and Z, and it says, fill in the blanks so that Z contains the following content. So what would you type in 1 and 2 so that you would end up with 2, 3, 4, 1, 2, 3, 2, 3, 4 again, 3, 4, 5, 4, 5, 6. So it looks, so pattern matching, we have that this seems to be the original value of Y. See that? But with a new value in the beginning, right? So for that to happen, we would need to somehow copy Y into Z at the end, and then in front of it, right, put it 2, 3, 4. So 1 would be 2, 3, 4. Right? So it would be, oops. This would be for this one. Oops. So 5, 1. So 1 would be 2, 3, 4. Also notice I'll always provide some hints on what not to type. So usually most of my input fields, the only thing I expect is simple characters, right? A through Z, right? Mostly all lowercase, right? Occasionally a capitalized. But typically all my answers, you should not use any special characters, punctuation, square brackets, parentheses, equal signs, right? None of that. Once in a while, the question does need for you to do some, use some of those. But without giving you away the answer, it says, okay, include special characters such as periods, commas, colons, semicolons. So notice that I don't say periods only because the answer is to do a dot, 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 right, operator at the end. So you say dot, 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 y, right? So I'll probably rewrite this question. And instead of asking you to use the special characters, I will put the dot, 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 right? So you don't have to even do the dot, dot, dot. You would just have to say y, and then that's it, right? Again, to minimize any errors of you typing the wrong character and trying to automate as much as possible the grading. So 1, so 1, 2, 3, 4, and then it would be dot, 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 y. Okay. Then question 6. Okay, so this is all right. So notice it says use params from React Router DOM. So this seems to be a routing question, right? So I'm guessing there'll be routes, links, right, paths, right, to, and so on and so forth. So this is a component called Jekyll, right, that has a parameter ASD that has an initial value of 9, 2, 8, and 3. And internally, it seems that it's using an object destructor, with a function that presumably returns an object of which we are extracting the DSA. So this, a hint here might be that this is maybe use params, right? Where we are extracting some path parameter. Here we seem to be accumulating something in an array, right, some value, and then we're copying some other array, The only other array here is this one. So probably this is the ASD. We're copying the old array here somehow, and then we are prepending something. It looks something like that. I don't know yet. And then we are rendering EWQ. It's a constant here that doesn't appear anywhere, right? The only possible place that it could be declared is that 6, right, is declaring this variable, right? Because it's we don't have any other variable declarations here, so that 6 probably has to be EWQ. Then we're returning the default Jekyll, right? Then we have a Bimini here that let's see, it's importing our Jekyll component. It's taking an argument, a parameter SDF that has initial value of 4. Right, so somebody needs to pass this along, right? And it has a route, right? It has a route which is using Jekyll here. So Jekyll here looks like it's only going to render if the URL looks like this /q11 some parameter name, right? So already we already know what this is, right? Because we have a parameter up there that has ASD. Right, that is extracting this from the params. I'm sorry, DSA, right? DSA, careful, right? So probably we this is use params, and we are extracting DSA from this parameter name. So this probably is DSA here. So this has to be element, right? Right, because it's a route. So this has to be element. So Jekyll. So it looks like this link pattern matches perfectly with this one. See that /q11 So probably by clicking this button is going to cause this route to render. Right? So initially, probably this Jekyll is not rendering, but when I click a button, Jekyll will render, and whatever this value is, it's whatever is going to be passed in here. Okay, it's the value of that. So let's see. So this is an expression that means that this is referencing some variable. Now the only other variable here, the only variable, it's SDF, right? It's the only value of so it's a good chance that this is SDF. It's the only variable here. This can't be a variable, right? This has to be a hard-coded piece of text, right? This also is element, so this this is probably SDF, and we don't know what the value is here. Okay, let's keep going. So it says, fill in the blanks above so that clicking so if I click on the button, it sets EWQ to an array that has 4, 9, 2, 8, and 3. So EWQ. So where's EWQ? It's way up here, right? Here's the EWQ. So this should render how? It should render with 4, 9, 2, 8, 3. So 4, 9, 8, 2, 8, 3. Oh, okay. Well, it's this array, right? But with a 4 in front of it. It's that same array with a 4 in front of it. So probably what we want 6 to be is whatever that is, and we want to prepend this with a 4, right? So 2 needs to be a 4 somehow, right? So this has to be EWQ, right? And this has to be ASD, copying this array, and we're going to prepend this to be 4. So 4 needs to be probably from DSA, that we're extracting it from a use params, yes? And DSA comes from, this would be DSA. We're passing the value, and the value would be whatever that is. That needs to be probably SDF, which has an initial value of 4, right? So it has an initial value of 4. So this is 4. QWE, they press it, 4 gets assigned to DSA. DSA gets parsed in for the use params, and that 4 then gets prepended in front of the array. Yes? Yes. Yeah, so right, so this path names the placeholders, right? And you give it a name. In this case, you can have any number of path parameters, right, with all the colons. And when the actual link matches the parameter, it creates useParams, creates an object who the keys of the objects are all these values. So DSA, ABC, XYZ, and the values of the objects, right, are the actual values that matched. Right? So if this is 4, then DSA would be 4, right? So what useParams does is that it returns a map, right? Where the keys are whatever I call them the routes, DSA, ABC, right? But the values will be the actual values in the URL. Okay, so here we're extracting the object, and then the particular property DSA, the key DSA, and it has the value of whatever is matched in the URL. Okay. So yeah, let's fill this out. So one would have to be SDF. So that's a SDF. And 2 would have to be DSA, because that's the component that we're expecting. 3 would have to be element. 4 would have to be 4. 5 would have to be useParams. 6 would need to be EWQ. And 7 would have to be ASD. I think that's it, right? Yeah. All right, so let's look at question 7. Okay, so before we looked at object constructors, right? That we were using a spreader operator with the array. This is probably a spreader question with objects. We have Q and W. We have an initial object Q that declares an object with 2 fields, A and B, with 1, 2, 3, and 2, 3, 4. And then we have another object W that has a placeholder, presumably for an object, maybe. Then we have property, value, property, value. And so the question is, well, fill in the blanks so that W ends up having these values, right? There has to be an A with 1, 2, 3, B with 3, 4, 5, and C with 4, 5, 6. Okay. All right, then let's see. So we have A 1, 2, 3. Right? We have B 2, 3, 4. We have, so what could we do? Perhaps, let's see. Say we don't use Q. If we don't use Q, can we do this without Q? Maybe. Now notice it says include special characters such as periods, commas, colons, semicolons, parentheses. Yeah, I don't like the question already, but let's see. We could say B 3, 4, 5. I guess 3 could be 3, 4, 5, right? C 4, 5, 6. I guess this could be C and this 4, 5, 6. That could work, right? Where can we get the A of equal 1, 2, 3? I guess for that, 1 would have to be A colon 1, 2, 3, right? So that's why I don't like this question already. But the intent of the question, I think I'm going to rewrite this question or fix it. Ideally, what would happen is that what you could do is that you spread over Q, dot, 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 Q, and that brings over the A 1, 2, 3, but it also brings over B 2, 3, 4. That's okay because we would override the B over here, right? We would override this to be something else, such as 3, 4, 5, which would override the 2, 3, 4. And then you just have C, right? 4, 5, 6. Anyway, that was the intent of the question, right? But again, right, it's ambiguous, right? Because you could do it in several ways. Either the spreader, right? or literally saying, A colon 1, 2, 3, which usually I would discourage you from using special characters, but this one looks like it is allowing you to do semicolons, right? So you could literally say, A colon 1, 2, 3, right? And do it like that. But I don't believe that was the intent of the question. So I will make sure that there are no ambiguities. So yeah, but the intent was being, dot, 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 Q, then C, then 3 here is 3, 4, 5. So 3 is 3, 4, 5. 4 is 5, 4, 5, 6. Careful that these are not necessarily in the order that you would expect as 1, 2, 3, 4, 5. It might jump. 1, 4, 2, 3. Careful. Okay. And then that's it, right? 1, 2, 3, 4. Okay. All right. Question 8. So we have two functions. We have or two components. We have component ASD, which is use params. Presumably, it's extracting parameters from the URL called XZC and ZCV. Then it's parsing them into integers, and then presumably it's going to subtract them, right? So we already have a hint that 7 and 8 probably is QWE minus WER or vice versa. We don't know. We don't know yet. Right? Then down here we have a browser router. Browser router is the equivalent to hash router, right? It's actually, there's a whole bunch of routers depending on what device you're using. I'm not using the browser router anymore because it doesn't work with Netlify, right? It works locally on our React.js, when you run it locally on your machine, but when you deploy it to React.js, it doesn't work on React.js. That's why I no longer use browser router, but it is entirely the equivalent of hash router, right? It does the same exact thing. It is the root component for the routing mechanism. Yes, right? So probably, I will update these questions so that it uses the hash router that you're familiar with, right? Anyway, here's a hash router, which actually maybe we don't even use. Let's see, what do we do here? We also have a params, which is parsing components QWE and WER, and it's returning what is returning? Well, this has a 2, so this kind of is giving us a hint that 6 is probably link, right? Link, and the name even says link, right? So it's a hyperlink that encodes the value of WER and QWE as part of the URL. And so basically this link is what gets rendered, right? REW basically renders this link, right? That encodes this into the route. So here's browser router. Here's browser router that declares a couple of routes and declares one link, right, that has a path, QWE 21, 14, and WER. And if you click it, presumably it's going to pattern match one of these routes. And so let's see. So if I click this link A, so let's see what the question says. Okay, so fill in the blank. Oh, I think I provided the answers. Fill in the blanks above so that if you click on link A and then click on link B, the browser renders a 7. Okay. All right. Okay, so let's see. So if we click on link A, what happens when you click on link A? So if you click on link A, we have, let's see, QWE, 21, 14, WER. And okay, so presumably if I click on this, it's gonna pattern match one of these two. Let's see which one. Okay, so it can't pattern match the second one, right? Because this has 1, 2, 3 places, whereas this one has 1, 2, 3, 4 places. And notice that it ends with WER, ends with WER, so it pattern matches this one, right? With two placeholders, right? With presumably QWE will bring the value 21 and WER brings the value 14. And this would have to be what for this to pattern match? This would have to be QWE, right? For this to pattern match. Okay. All right. So if I click on it, this will render. Okay. So I don't know what that is. Now, what happens if that renders? Notice it says if you click on link A, then then something happens, right? Then you would need to also then click on link B, but there is no link B. Right? Notice that link B only appears when I click on link A, right? If I click on link A, pattern matches this, and what does it render? Here's link B, right? So that means that the component that gets rendered for would need to be this component, right? RAW, for the link to appear, right? Then the link appears. Now I see the link. And what does the link do? It parses out QWE and WER, the two placeholders, QWE and WER. It parses out those placeholders with values 21 and 14, right? 21 and 14. So this would be 21 and 14, right? These two values would be 21. And what does it do? It creates a new link. That link, right? Encodes /AESD 21 and 14. I don't know which one. I have to figure out, I don't remember. So 21 and 14. So now I have link B. Now if I click on link B, it pattern matches against this one. See that? Pattern matches against this one with 21 and 14. Right? 21 and 14 encoded. And this renders who? Renders ASD. And ASD parses out the two placeholders, right? These two placeholders, ZXC and XCV, ZXC and XCV, one of them 21 and the other one 14. Again, I don't remember which one. And just subtracts 21 minus 14, you get the 7. Yes? Does that make sense? Right? So anyway, I'm not gonna copy the answers. Looks like the answers are already here. Right? So I'm gonna skip over that. All right, 9. All right, so 9 is again playing around with arrays. So let's see. So question 9, question 8. See answers on PDF. So question 9. So the reason I use all these random variable names is I remember taking a quiz in electronics, and most of us didn't do very well, right? And so after the quiz, right, when we were reviewing it with our instructor, he just turned the page upside down, and then it totally makes sense, right? It's obvious once he turned it upside down and you saw the resistors and transistors, right, in a particular configuration. It was obvious what it's supposed to do, right, and the answers would just come out. Same thing with algorithms, right? If you see an algorithm with just random names, you don't know what it's doing, right? But if you give the correct names for the functions and the variable names, it's obvious what it's doing, right? So you don't even have to think, right? That's why we often ask you to, when you write code, that you use meaningful names, right? It's so much easier to understand what it's doing. So I guess the point is that if I use real names, none of these algorithms would be any challenge. You wouldn't even have to think about it, right? You would just run through them. But I do want you to stop and go through the puzzles, right? And actually run it in your head, right? So that's why I insist on random variable names. Where was I? Okay, so question 9. So here I have an array, EWQ, blah, 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 blah. And says, and then we're doing some, probably Q1 is Q, right? And then we're doing something with the array. Okay, so fill in the blanks so that W ends up equal to QWE, meaning that probably we want to extract the value QWE from this array. Right? So probably want to go and find the value that causes W to be this whole thing to evaluate to QWE. Yes, right. So I guess this it could be done. This probably can be done in 2 ways, right? We could this is iterating over the values, right? EWQ, DSA, QWE, blah blah blah. So what we could do is, if B is equal to QWE, this whole thing evaluates to QWE. Yes? Or you can also do it with the index. So A is also an index. Right? You could say, if A is equal to 0, 1, 2, right, 2, then this also evaluates to QWE. Yes? And so both answers would be okay. You do it one way or the other. I guess you could have 2 more, right? If you invert these, right, you could say if QWE is equal to A, or if 2 is equal to B, right? You could do that way too. Or I'm sorry, if QWE is equal to B, right, or 2 is equal to A, right? So I guess this would be 1 is Q, 2 is find, and then 3 is either B or what? What did I say? B or 2? And this would be A. Oh, sorry, no. So 3 is QWE. Oh, no, wait. So this is B or A, and then QWE or 2. Right? I think so, right? Is that right? Yeah, so you can do either B is equal to QWE or A is equal to 2. All right, so question 10. So question 10, I think you've seen this in one of the quizzes, right? We give you a couple of check boxes. We kind of like try to throw you off with name equal to radio, right? But they're obviously check boxes, right? And the name is irrelevant, right? The name is irrelevant. It could be XYZ, it doesn't matter. The only point here is that they are the same value, right? They're the same value. Not necessarily have to have any particular value, but they're the same. So they're grouped, right? They're grouped. So fill in the blanks below to implement the behavior described. Consider the following set of buttons. If the user clicks on the text, the button on its left is selected. Right? So there's 2 ways to do that, right? We either have a label that has a for attribute equal to the ID of the checkbox, or we can wrap the whole checkbox in a label, right? Without the need of an ID and a for. Yes? Can be done 2 ways. So this way, looks like they're asking us to use the second, the second strategy. Notice that we have 2 and 2 seem to be wrapping the whole input field. So this is a label. And then we have the input field of type checkbox, right? Where the ID is ABC, but it's irrelevant. It doesn't have to be the ID, right? The ID doesn't matter here. If this were a label outside, then yes, the ID would have to be matched with the for attribute. Yes, right? So 1 here is checkbox. 2 is label. And 3 is input. All right? Okay. Question 11. Okay, so we have, oh, here's another one of those, right? Oh, here's another one of those, okay. Okay, so we have ASD. So there's a component ASD that declares an array EWQ and a function called tre that presumably we can click that notice that there's a button. Presumably we're going to on click and we're going to invoke a function. The only function here is tre, so this must be tre. And we're passing 2 arguments, right, of which the second one is 999. So UYT must be 999. And then this first argument must be the same as this 2 over here. Okay, so this is on click over here. So what are we doing? We're being asked to say, okay, fill in the blanks below so that clicking the button, the console prints the following: 321, 432, 999, 654, and then 765. So what is that array? Looks like it's that same array. See that? It's the same array, the array EWQ, but with one of the values substituted with 999, basically. Yeah. Meaning this function, probably when we click on it, it needs to replace. Right? It's going to take the original array EWQ. So it takes the original EWQ array. It's going to compute a new array. So this must be probably map, right? And it's mapping over the array, and passing each parameter here. And what are we doing here? We're saying, well, if the particular value is equal, so this probably is IUY, right? The parameter that we're iterating over. If it's equal to YTR probably needs to be that 999, right? If we find it, oh wait, no. It would need to be what? Probably we want to replace this guy, right? 543. So how do we get that? I guess it could, no, YTR. How do we get where do we get YTR? Where do we get YTR? Oh, okay. Probably from here, right? So we pass in YTR to be compared, right? So we're comparing one at a time. We compare one at a time with YTR, right? We pass here, and then if we find it, then we replace it with the 999. Otherwise, we keep the original IUY, right? So this has to be the 2 here, right? Wait a minute. This needs, oh no, the second argument, right? UYT. So this must be UYT. So if it's YTR, and we pass here the 453, so we pass in 453. So if it finds 453, YTR, if it is, then we replace it with UYT, which is 999. Otherwise, we keep the original IUY. That is what we're iterating over. See that? Okay. And then when we display it, we display the result, POI. So this must be the variable that, right, that we are displaying, which is the new array that includes, it's the original array with this one replaced. Okay. Yeah. Okay. So let's see. So one must be EWQ. 2 must be YTR. 3 must be UYT. 4 must be map. 5 must be POI. So this is the only way that this could work, right? Oh wait, no. 5 is IUY, sorry. 6 is POI. Sorry. IUY, right? IUY, this one, right? Then 6 is POI. Uh, 7 must be on click. And 8 must be tray. I think, 9 must be 543. Okay. All right. Okay, so let's look at 12. Okay, so here we have an array, 51, 42, 33, 24, and 15. And so we're saying, fill in the blanks so that B is equal to 2. So again, it's probably we're iterating over Q, and probably we're finding something, right? So this needs to be reduced into the value 2. So that array needs to be reduced. So probably is finding something here, or returning an index maybe, right? So let's see if it's find. So find returns the actual value, So that won't work, right? So probably it's find index. Let's try find index. So find index, as it's iterating over each one, probably W, right? So if W, so when W is equal to what? So 2, this has to be evaluated to the index 2. So 0, 1, 2. So 2 must be 33, right? So yeah, so let's write that down. So 1 must be W. So 2 must be 33. So 3 must be Q. And 4 must be find index, right? Find index. Question 3. Another Jekyll. Okay, so we have a Jekyll component that has, so 1 is we're declaring an object with a key and a value pair. Then 2 is a function that when we invoke it, it prints out ewq.ert. So presumably we are referencing an object called ewq that's not declared anywhere else. So this must be 1 must be ewq, and presumably there's a property called ert in that object. So 3 must be ert, right? So let's see. So 1 must be ewq. 2 must be the name of the function. We don't know the name of the function, although we do have a function being invoked here, right? And so it's the only function here. So that must be the name of the function, right? So 2 must be WER. So 3 must be ERT. Okay, and so we're calling, so if fill in the blanks above, so the console prints 1 if you click on LVP 4 times and button POI 3 times in that order, right? So we click LVP. So we have 2 buttons, right? LVP and POI. So if we if we press LVP 4 times, and then after that you press POI 3 times, console prints out 1. Right? Let's do that. Let's see. So what is this doing? So if we click on LVP, what are we doing? We are taking an object that we have already established. Oops. QWE. And this is EWQ. It's referencing 2 objects, but there's only one. So this is a typo, right? There's only one object. That's the only object over there. Oh, wait. Oh, no. It's okay, because this is a parameter, right? That's a parameter. That's a parameter. Okay. Oh, okay. So it's a parameter. So this cannot be EWQ. Sorry. The 1 is not necessarily EWQ. It must be QWE. All right. See, QWE. Yes. Right. This is okay. It's taking that object. It's copying it over. Right. And notice that it's overwriting the old value of ERT by adding 1 to it. Right. So basically, clicking LVP, it's incrementing that 4. Right. And whatever it was, it becomes 4. 4 more. We don't know where it started. It's whatever it was. I don't know what it is. Right? But it increments it by 4. And whereas pressed in POI, probably it's calling the same WER. There's only one function, so this must be WER. So it's copying QWE, but right, it's decrementing, right, by 3. So if we add 4 and we decrement 3 2 times, so that's 6. So it's adding 4 and subtracting 6, right? So it has to end up to be a 1, right? So if you do the math, I think it comes out to be what? I don't know. So if this is 3, so it's basically updating this, right? So 3 plus 4, right, becomes 7. Minus 6 is 1. So this has to be, what did I say? 3? I said 3, right? Yeah, so this has to be 3 plus 4 is 7, minus 6 is 1. Yes.
So you're setting 4 to be the initial value. Where is it?
Yeah, so what is the value? What would be, what does it have to be the initial value, right, of ERT, so that if you add 4 and subtract 6, you end up with 1? Because it says that the console prints 1 if you press this 4 times and POI, 3 times, sorry. So the math is a little bit different. So figure out what the math is. So that's 3 less, so it must be 3, so it must be 6. Right, so 6 plus 4 is 10, minus 9 is 1, right? So let's do that. So 1 is QWE, 2 is WER, 3 is what? ERT, 4 must be 6, right? And what else? 5, there's no 5? Okay, that's it. All right, so here's an easier one, question 14. So consider the following radio buttons. So this is telling you it's a radio button. One set of radio buttons is for choosing a single color, and the other set of radio buttons is for choosing a single movie genre. So we have 3 radio buttons: yellow, blue, red, and horror, comedy, drama. And so the one one already needs to be what? Needs to be input, obviously, yes. So 1 needs to be input. 2 is, they say it's a radio, so 2 must be radio. So 3, and so okay, so we want these to be mutually exclusive, right? But in 2 separate groups, right? We want yellow, blue, and red to be mutually exclusive amongst each other. And we want horror, comedy, and drama to, again, be mutually exclusive amongst each other. But they should not affect the two groups, right? Clicking on comedy should not affect the color, right? Which color is selected, right? So there has to be two groups. So the way we group radio buttons is by setting their names the same, yes? So 3 must be named. And then here, 4, 5, 6, 7, 8, and 9. So we need to group these together. So it says, using the strings color and genre, fill in the blanks above to group the radio buttons into a color group and a genre group. Right? So that you can select only one color and only one genre. But selecting a color does not affect selecting a genre. Yes? All right, so for that to be the case, 4, 5, and 6 need to be the same, right? And 7, 8, and 9 need to be the same. Yes? And they're saying to use color and genre. So 4, 5, and 6 need to be color. So 4, 5, and 6 are color, whereas 7, 8, and 9 are all genre. Yes? Right? Okay. All right. I see what's going on. I think for this exam, I had not yet covered useState, right? And so that's why I'm going out of my way to using these let constants, because I do want to use the state, but I had not covered state yet. So these questions probably should all have these variables be state variables using useState. Okay, but I had not yet covered it. Okay, all right, never mind. Nevertheless, and all these presumably would have been set something, right? Anyway, okay, so we have this component XYZ, which takes a default parameter, right? And it has a default, a property that has a default value 2. Then we're declaring a variable that copies the value of QWE, right? That must be 1, right? Otherwise, we would get a syntax error, right? That we are using a variable that hasn't been declared yet. So 1 must be QWE, right? So this is a 15. So 1 must be QWE. Then, yeah, it's being copied onto 3. Then we're declaring so these are 2 functions. We're declaring 2 functions. We don't know their names, but one takes an argument, whereas the other one doesn't. So this function is, okay, this function is what? It's copying the parameter into REW, and REW is not being declared, so it must be declared elsewhere, right? So it must be either the variable declared here or the one declared there. Well, it can't be this one because those are constants, right? When you declare these, so you can't change them. So that this would cause a syntax error if this were REW. So it must be this one because it's the only place where we're declaring it. Well, unless, yeah, no, it's the only place where we're declaring. So 3 must be REW. Then we have a function call, blah, blah, blah. This is copying over the value of W, so it's resetting it, I guess. Here's another function call. It looks like this function call is calling another function call. Now, the only other function call is this one, right? Well, unless we have a recursive call, right? Like an infinite call. So probably it's not calling itself. So probably this one is, it's this one. Notice it's the only one that takes an argument. So it must be this one, right? So 4 must be ERT. Okay, let's see, what else? Then we have here a button that looks like it's a fill in the blank, so that clicking the button twice, the console displays 20. Right. So the only console is this. The only console is this one over here. So let's see. And the only way we can call this function is that if we have an on click, so 6 must be on click, right? And if it's on click, it's going to call a function ASD. So this must be ASD. It's the only other function. So 5 must be ASD. And so if I click on it, what does it do? It calls ERT with a value of REW. So REW, I think we've already established that it's this here, 3, right? REW, plus 5. So whatever that is, plus 5, and it prints out 5. Oh, well, it's whatever REW is. We don't know what the initial value of REW is. It's whatever QWE is. So we have to know what the initial value is. So it says that if we press it twice, it displays 20. So that means that if I press it twice, I'm adding 5 twice. So I'm at the end adding 10, right? So that means that the initial value must be already 10, so that if I add 5 twice, it becomes 20. Yes. So that means that REW must be 20. It must be 10 at first. So 2 is 10. And so that now it works out, right? I think I'm all set, right? 6. I got all of them. All right. 16. All right, so here's several spreader operators, right? We have QWE and CXZ. We have looks like there's some spreading going on. So fill in the blank above so that the console prints out 456 and then 654. So ASD must be 456 and this must be 654. So ASD is 654. So where do we get ASD? So this is equal to something that is going to be destructed, right? So there must be properties here that are called SDF and ASD, which we're going to destruct somewhere, right? So let's see. Can we find any 654 or 456? Okay. So there's 456. There's 654 up there. So if we destruct CXZ and 3 is SDF, no, sorry, ASD, right? If this is ASD, then we would be able to destruct it, and so ASD is 456, and then it would print out 456. So this is 456. So this must be ASD. So 3 must be ASD, right? So that we can destruct it. So 3 must be ASD. And SDF is 654. Let's see. So here we're destructing CXZ. That's what we're saying, right? So one here is CXZ. CXZ. And so that's what we would get here, the ASD. But where are we getting this 654? 654. Let's see. Looks like we are spreading this on top of that, right? And copying over the 654. And if we do that, this becomes what? So let's say that 2 would be SDF. So SDF. So this would be SDF with the 345. That's not what we want, but that's okay because we are spreading this. We're copying this whole thing across. So we would get SDF again with 654, which would override the SDF over here, which is okay. So that's only to throw you off, right? So because we're going to have SDF twice, right? We're going to have SDF declared as 345, but then it's going to be redeclared again with SDF 654, which is going to override the old SDF. Yes? Right? Okay, so even though this is SDF, the 345 later on is going to be 654, right? So it's good. So two can be SDF, right? Oh, here's another one that was trying to throw you off, right? If 3 is ASD, notice that we're spreading it, so we would get ASD is 1, 2, 3, but then we get ASD overriding the old ASD to be 4, 5, 6, which is perfect, right? Right. So okay, so then 2 is SDF, and I think that works out. I think this is a question that was in one of the quizzes. We have yeah, so let's go over the quiz, right? And the quiz says we have a header, a heading that says, you know, I'm white on red. So its foreground color is white and the background color is red, basically, right? So here we have two attributes, different values, QWE and WER. And these could be all sorts of things, right? It could be title, it could be ID, it could be class, right? It could be name, right? It could be anything. But here we're giving a couple of examples on what are we doing with QWE and what are we doing with WER. Right? This is saying, well, what if QWE were an ID, right? If it were an ID and it would set the background color to red. So this would be an ID. This rule would cause the whole thing of background to be red, which is what we want. Yes? Right, so maybe that's good, right? That you know, to cause this to be true, then this would have to be ID. Okay? All right, so if that's true, I can't use ID twice. So I can't say ID QWE and then ID WER. Right? Both of them can't be true. I can't have both attributes to be ID, even though the browser might be lenient and let you actually do it. Right? It is a syntactical error. Right? Okay, so if I go with that hypothesis, this is ID QWE. It gives me the background color red. That means that this has to be a class. If this is an ID, this has to be a class. Right, that means that it would be this ID with this class. Yes? Right, and this would give me the background color to be blue, but the color to be white. So would that work? Because there's a collision here, right? The ID says that the background is red, but the class says that the background is blue. But it gives me the foreground color white that I do want. So would that work? You know, with this collision? Well, I would, right? Because an ID selector has higher priority than a class selector. So you would get the background red and the foreground color white, right? It's not ideal because you do have a clash. So we can check the other one to see if the other hypothesis would be that this is the class and this is the ID backwards, right? So let's see. If I had the class QWE, that would give me the background color red and the foreground color white, which I want. But the ID WER would give the background color blue, right? So again, I would have a clash where one rule says that it's red and the other one says it's blue. But in this case, the ID WER would win over the class, right? So it would give me a background blue. So that's not what I want. So it has to be that this is ID and this is class. Make sense? Right? So one is ID and the other one is class. Oh, it renders like that? No, I think on the browser it does render correctly. All right, so here's another one. So here we have, so this is question 18. So here we have QWE that's equal to, we don't know yet. But it says fill in the blank above so that the console prints 321 and then 234. So EW key is, so EW key must be 321 and REW must be 234. So EWQ, so looks like what we're doing here is that we are destructing ZXC using the array destructor syntax, right? So let's see. So here's 321. So there's a 321. So this is destructing the first two items of an array. So maybe this is an array. I don't know. I don't think it's an array. Looks like it's being used. ASD is being used for here, and QWE is being used to fill this in, right? And this array destruction is only caring about the first two items. So if this were ZXC and we are destructing it, we only really care about the first two items, right? It's ignoring the last three. Yes? Right? So it's extracting these two items. So this 321 would go here, and whatever the QWE is would go in the second. So if this is 321 would go here, and it's printing 321, then one must be EWQ. Yes? So one must be EWQ. So this REW must be in the second part here. So 2 is REW. But it's grabbing whatever value QWE is, right? But it must be, so QWE must be 234, right, for this to work. So 3 must be 234. Okay. Let's see. Here we have QWE is a functional component that evaluates to a heading that multiplies the values of its properties. And it's multiplying ZXC multiplied by some other property, which must be 3, right? So 3 must be ASD. And so fill in the blanks above so that the browser renders a 9. So this must be 9. And the way we're calling QWE, we're passing ASD. So this must be called ASD. Okay, we have confirmation that this must be ASD. And so it is ASD. We're passing some value. Whereas here, this must be ZXC. We're passing a 9. So here's 9 times whatever that is, right? Must give you a 9. So it must be a 1. So this must be 1, and this must be ZXC. So 1 is ZXC. ZXC must be 1. So ZXC. And 2 is the value that we pass must be a 1. 9 times 1 is 9. Question 20. So here we have you consider the following code snippet. So we're giving you an array. It says, okay, fill in the blanks so that W at the end contains the following values. So 3, 4, and 5. Meaning you have these values originally in Q that probably we're iterating over Q, and we're only returning the values 3, 4, and 5. Right? So somehow we're filtering out the first two. So map doesn't work because map returns an array of the same length. The only one that we know that returns a smaller array is filter. Right? Filter is the one who filters out certain values. So it would be q.filter, and then notice there's a greater sign here. So it must be that as you're iterating over A, you're only keeping the values that are greater than something. Right? Probably the ones that are greater than 2, which give you 3, 4, 5. So A greater than 2, right? So it would be 1. So this is question 20. So 1 is Q. 2 is filter, 3 is A, and the other one is 2. 21. So 21 is fill in the blank below so that clicking the button, the resulting output in the console is 1, 2, 3, 2, 3, 4, 4, 5, 6, 5, 6, 7. Okay, so this is very similar to the earlier question. We're manipulating an array, and then we are, the name of the function kind of gives it away, right? That we're deleting a particular value, in this case 3, 4, 5, right? So that we end up with the same array but accept that value. So again, so 7 is probably on click, right? And we're going to call the function ERT. The only function here that doesn't have a name is this one, so 1 must be ERT. So it's ERT. And so ERT, and we're passing probably